This unit, we're going to be discussing dimensions and units. Now, dimension and units seem very simple, and really, they are very simple, but they're also one of the most powerful and useful tools in all of physics. Now, first we have to look at what they are. A dimension is any unit of measurement. For instance, if you measure how tall I am, you would notice that I'm 6'1", 6 feet, 1 inch, and that dimension represents my height. Now, a unit is anything that says what a number means. In this case, the units are feet and inches. Or I could turn that entirely into inches, where I'm 73 inches. If I don't give you a unit, if I just say I'm 73 tall, that's not very helpful. Am I 73 inches? Am I 73 centimeters? Am I 73 microns? Those would give you fantastically different results. So it's very important that anytime you measure something, you have the correct units. For our purposes, we're going to be using something called the SI, which is short for System International, System of Units. Now there are 7 SI units. In this case, we're only going to be using the basic 3, which are meters, seconds, and kilograms. Meters are a unit of distance. For those of you not familiar with metric, it's about 3.1 feet. Seconds is a unit of time. And kilograms is also a unit of mass, which is also metric. It's about 2.2 pounds. Now, by combining and using these units in different ways, we can actually get all of the different measurements of units that will be needed for this class. For instance, meters, which is distance, and seconds, which is time, a little stopwatch there, can be combined to give meters per second, which is the measurement of velocity. So by combining these and recombining these different ways, we can get all the different units, and we can actually check to make sure that our answers are right. For instance, if you're asked in a physics problem, how long does it take you to run a certain distance? You can look at that and you can say, okay, how long? It's looking for a time. And that means if you get an answer in meters or kilograms or meters per second, you know your answer is wrong. Your answer needs to be in a time. It can be in seconds, it can be in minutes, it can be in hours. If you're running a really long distance, it could be in years. But above all, it has to have the right units or you know you did something wrong. And just because you have the right units doesn't mean it's right, but it does give you a good hint. It tells you you probably did the right stuff along the way. And if you're wrong, you may have made a multiplication or division error, but had the right thought process. Now, sometimes the correct units is no units at all. And this is fairly rare, but this happens when you're looking at ratios a lot of times. For instance, if I were looking at the ratio of my height, this one's me, to my friend's height, over here. Apparently I can't spell today. We would say the ratio is my height, 6 feet, divided by her height, 5 feet. And that ratio, the units, feet, cancels out. We have feet divided by feet, which just gives us nothing. And the ratio is 6 to 5, or 1.2. So in this case, this quantity is what we call dimensionless. There are no units associated with it. It's just a number. However, for the most part, that's very rare. Either you should have an SI unit, meters, seconds, kilograms, or other ones that we'll get to later in this course, or you should need some special unit. For instance, if I asked you to count jelly beans, your answer would be in jelly beans. Or if you're a chicken farmer and you're saying how many chickens fit in a coop, your answer might be 72 chickens. We'll say chick is the unit for chickens per coop. So a lot of times you can solve very complicated problems by just starting by looking at the units and figuring out how do I get these units to match up with what the units of my answer will be. So I'll give you some problems on that, and then we'll go into a more advanced concept next time.